In this video, we are going to talk about how do you create PCOMP entries that define your laminates for MSC Nastran. So here in this image is a look at what our composite laminate looks like at the end of the video. So here we've defined 8 layers, it's symmetric. I'm going to talk about how do you create the so-called PCOMP entry like you see here on the screen. And I'm going to talk about orienting your 0-degree direction for your elements. A lot of tutorials will leave that out. So what does the 0-degree direction look like for this example? So here we'll go to the FEM label tool and we'll display the material coordinate systems. And here for this example, we have a problem. The 0-degree direction for layers are different from element to element. So if you look at the red axis here, the red axis is pointing to the left, but this element, the red axis, is pointing a little up. The red axis in the material coordinate system, that's the 0-degree direction. So a lot of tutorials, they will show you how to create the PCOMP entry, but then they stop there and they completely leave out the fact that you have to orient the 0-degree direction for your laminate, if you will. Here on these other elements, these are corrected directions. So here, all the 0-degree directions for each element are going in the rightward direction. They're all parallel, if you will. This is what we want. And then if we look at these other elements, you can see the 0-degree direction. They're all in different directions. And then if we do this for the other wall, they're also in completely different directions. Now, the story starts in Patran. Maybe you've defined a PCOMP entry successfully, but now you're kind of wondering, okay, how do I orient the 0-degree direction for all of my elements? You would export the bulk data file, like this example, and then you would bring it to the web app, and then it's here where we're going to go ahead and make the modifications. Now, the web app that we're working with today, there is a free trial of this web application available today. If you visit theengineeringlab.com, at the top right hand corner, you can click on free trial pre-post web app. You can fill out the form, and then we'll go ahead and grant you access to this web app. Now, to start off with, once you get a link to the web app, you can go to the Soul 200 web app and click on the viewer here on the right. Here you can click on upload, select the bulk data file that you want to modify. Now, one useful thing about this web application, you can use this to fine-tune existing Nastran models. Maybe you use Patran to build this model. Maybe you use VMAP or HyperMesh or some other tool out there in the wild. You can use this tool, this web application, to make small modifications that you want. So here is our starting composite, if you will. Maybe while inspecting this model, we found out that maybe the layers for the laminate were too thin. We have to correct that. So what we can do, we can go to let me first hide all these layers. What I can do, I can click on the pre button. This is going to open the pre panel. You can go to PCOMP, and then here we have PCOMP 1. This is what we want to fine tune. So what we're going to do, let's go ahead and delete, and I think it might be worth moving this to the left a little. Let's go ahead and remove these old layers. And now we have no layer. Let's go ahead and add 4 rows as an example. Here, let's go ahead and select mat 8, which is our orthotropic material. And then for the thickness, you can go ahead and specify these one by one. So you can go ahead and copy and paste, or you can use this row here. You can type in one value and click this button. So let me delete all the rows for now. When you click this one button, it's going to apply that value to every visible row. So it's kind of a time saver. Let's go ahead and update theta. Maybe this first layer has an angle of 90, then 45, then negative 45, and then 0. And then you can see that the bulk data entry here on the right is immediately updated for you. Now, whenever you make a modification, this is going to go ahead and update what you see on the screen. So again, if we, let's move this a little, let's go ahead and maybe do this. Let's add an additional row. And here on the right, we'll go ahead and say use that orthotropic material, use the same thickness, but here maybe the angle is 35 degrees or 34. And now we have a angle with 34 degrees. Let's go ahead and use something different, maybe 68 degrees. I'm just randomly picking these angles. And that would be the purple layer. So anytime you make a modification to the PCOMP entry, it's immediately updated for you on the screen. Now here we'll say, oh, you know what, the layers are still too big. Let's go ahead and maybe adjust this to 0.00125 and click apply here. And here we'll say, you know what, okay, the thickness of these layers is more to my liking now. You could continue experimenting with the PCOMP entry. There's another video where I go into more detail on the PCOMP entry, so I recommend watching that video. Maybe I'll put a link to that video in the description below. Okay, so now we're done with the laminate. And now we have to worry about the direction of the 0 degrees for each element. Now, you have to do this whether it's a mesh with 2D elements or examples would be, let me just show you actually. The 0 degree direction will matter whether you're using the triangular elements like we did in this window or quadrilateral elements like you see here. If we do the following, you can go to orientations and click on display MCS, and we'll do that for the other window too. Click on orientations and click display MCS. This will show you what the 0 degree direction is for each element. If you're dealing with quadrilateral elements that you see here, the change of the 0 degree direction is very subtle. It's very small. Sometimes you might even miss it. Here is an example where maybe for the bottom elements, this is the 0 degree direction that we want. But for these other elements here, you can see the 0 degree direction kind of pointing downward. That is not what we want. If we look here, you can see that the 0 degree direction, it kind of varies when you're going from element to element. And then we do that here, same story. The 0 degree direction is just completely different when you go from element to element. And then here, if we look at the triangular elements, this is where we see, okay, we have a very big problem here. So again, if it's a quadrilateral element, the difference is very small, but it's there. Same story for the triangular elements. But it's even more pronounced. The 0 degree directions are going in completely different directions. Now, one thing I like to do very often, for each coordinate system, I like to show you a stick figure. It's in this stick figures frame of reference. It's in the stick figures local coordinate system that the stiffness values are being observed in. If this was stress, it's in this person's, here, if this was a 0 degree layer, it's in this observer's coordinate system, if you will. We're observing the stress in the 1 or the 2 direction. But guess what? If you go to an adjacent element, guess what? This observer's coordinate system is completely different. If it was the stress along the 1 axis, which would be the red axis, this person is going to view it a little differently from the neighbor, if you will. So we have to fix this. We have to tell every observer, hey, point in the direction that we want. So here, what we're going to do in the orientations panel, we're going to select 2D elements, and we're going to select this first option, theta based on vector G1. And we're going to say, you know what? I want all of my 0 degree directions for these elements. I want them to go in the negative y direction. So say, negative y direction, which would be this direction, if you will. So we can define a vector from this node to this node. So we'll click on grid 1, click plus, and the picking sphere is too big. So let's reduce the size of this. Let's go ahead and pick this first node. It's been selected. And then let's pick the second node here. And so we're saying, hey, you know what? Take all these elements here and make their 0 degree directions parallel to this vector that we just defined here. So the vector goes from this node to this node. And now let's go ahead and select the 2D elements we want to modify. So that would be these elements here. And then once you did the selection there, click apply. And there you have it. That was a change. Now it's very subtle, so let's go ahead and take a step back. So this is before the modification. So all the 0 degree directions are in completely different directions. And then this is after. Notice one thing. There was an angle that was done to reorient these coordinate systems. So here, for this example here, maybe the coordinate system was rotated maybe 90 degrees, maybe 80 degrees, somewhere along those lines. So each coordinate system was rotated by some angle, some theta. Now, if you go to the pre-web app and you look at the 2D elements, let's go ahead and look at those right now. Let's go ahead and display some more elements. Let's go ahead and display maybe 50 per page. If you look through some of the rows, some of the elements now have thetas in this column, theta / MCID. So these elements that have a theta value, these are the elements that we modified. And you notice that the other elements have theta blank. That means those material coordinate systems are not modified. Here, just to show, these are the triangular elements here in this left column. So now these blank thetas, these are going to be the other elements that we have yet to modify. So let's go ahead and continue the modification process. So let's go ahead and maybe modify these elements here. So like before, let's go ahead and select a new node. So we'll say start from this node here. Oh, let me reset the display. If you have a lot of data, a lot of visual objects on the screen, this makes picking a little more difficult, so you can reset that and then try again. So let me make sure I'm doing this right. Okay, let's go ahead. Okay, so I've selected that node. Let's go ahead and select the next node. So let me summarize what I did here. I've selected this node here. And then I've selected the second node here. So now I'm created a vector from this node to this node. And now for the beam elements, let me go ahead and delete all the old element IDs, and let me go ahead and select these 2D elements. And then once you're comfortable with that modification, we'll click apply. And now you'll notice that all the 0 degree directions are pointing in the same direction, which is what we want. And let's go ahead and repeat for this example. So here, all the 0 degree directions are in completely different directions. So we'll do the same thing. First, let's go ahead and delete the old IDs. And then let's go ahead and select one node. Now, it doesn't have to be a node on the edge. It can be any nodes that you want. So here as an example, let's see if this will work here. And I always need to reset the display. All right. Let's suppose that we pick these two nodes. So I've picked this node, and then I've picked the second node. So the vector is going from point 1 to point 2. Let's go ahead and select these 2D elements. And you'll notice that the vector I defined there, those nodes, they're not in the direction that I want. But I wanted to prove to you that the 0 degree directions are following that vector we defined with point 1 and point 2. And now you can see that, I didn't define the vector correctly, so let me redo this again. Okay, so let's go ahead and do this. Let me select a different node. So maybe we'll deselect that and select this node on the edge, and then we'll do the same for this one. We'll select this node. Let's go ahead and deselect this one. And click apply. So this was before. So here on the bottom right, I'm clicking on display ECS. And then I click on display MCS. So the 0 degree direction is defined by the material coordinate system. So that's what MCS stands for, material coordinate system. So the ECS is the default direction, and then the MCS, this is what's ultimately used for the direction of the 0 degree axis, if you will. And then let's go ahead and repeat the process for this wall, if you will. Let's go ahead and reset this. Let me just go ahead and delete all of these values for now. And then let's go ahead and select a new node. We'll pick this node here, this next node here, and then for the element IDs, we'll select these elements here. And then apply. So there we go. So you can imagine if this was a laminate, we would drape our fiber along this direction. It would go around the corner along this direction. It would continue draping our fiber until we're going in this direction on the other side of the box. Whereas before, the finite element model had the 0 degree direction going in completely different directions. So again, a lot of tutorials will leave this part out. And they'll skip it. So then when you go ahead and you build your laminate, you configure your analysis, you're not aware of this discrepancy. You're not aware that your elements are using completely different 0 degree directions. So what I wanted to do in this tutorial, I wanted to show you how to modify the 0 degree direction like you saw here in the video. Now, so far we've used the node method. We use different nodes to define a vector, and then that vector was used to align the 0 degree directions. There's an alternative way. If you look at this option under field name, theta based on vector x1, x2, x3, you can actually specify a vector in the basic coordinate system that defines the direction of your 0 degree direction. So here what I'm going to do, I'm going to select all the 2D elements. Let me go here and select all of these. Sometimes it helps if you use a bigger picking sphere. So let's go ahead and do that here. So here what we're going to say, you know what, take all those elements and align them to this vector. 1, 0, 0. And then wait a moment and then click apply. And then you can see the 0 degree direction for all these elements. They're all pointing along the x-axis. If you look at the bottom left, that would be your x-axis. And if we look at the other walls, they're all pointing in the same direction. So there are different ways of specifying the direction of the 0 degree axis. You can use nodes that define a vector, and then the 0 degree direction is parallel to that vector, or you can manually specify that vector like we did here in a moment ago. There is another option. You can use a material coordinate system, or rather you can use a coordinate system that you may have defined. So here for this next part of the tutorial, let me do this. It's the same, I'll call it a box. It's the same box from this example, but here we're using quadrilateral elements. If you look at the material coordinate system, you can see that the 0 degree direction, it seems consistent, but if you look very carefully, you can see the 0 degree direction is kind of going at an angle here, but here it's going in the positive x direction. So we have to fix this. An alternative to using vectors, you can use the axes of coordinate systems. So let me do this. Let me turn on these labels. So here we have the basic coordinate system. It has an identification number of 0. Here we have coordinate systems 2, 3, and 4. What we can do, we can say, you know what, use the x-axis of this coordinate system to align the 0 degree direction. Use the x-axis here of this coordinate system or the x-axis of this coordinate system. So how do we do that in the web app? So let's go ahead and do that real quick. Click on the orientations panel, click target, 2D elements, select MCID. And then for this first example, let's go ahead and rotate this a little. We are going to adjust the direction. These labels are getting in the way, so let me turn them off. Let's adjust these elements first. So let's go ahead and select 2D elements here. The picking sphere is a little too big. So let's go ahead and select these. So we're going to say, you know what, take the 0 degree direction for these elements, make them parallel to this x-axis of this coordinate system. So we'll click on coordinate system ID, the pick icon, we'll click on plus, we'll select this coordinate system. Notice that it turns blue. Now be careful because the color is very subtle, you might miss it. Here you see we've selected that coordinate system ID, identification number, and then we'll click apply. Let me zoom out before I click apply. And now if we look underneath, you can see the adjustments. Let me show you what it was before and then after. Before and then after. You can see that the 0 degree direction is parallel to this coordinate system that we selected a moment ago. Now let's do this for this right wall, if you will. We have this other coordinate system here. I want to say take all these 0 degree directions and make them parallel to this coordinate system x-axis. So it's the same thing like before. We'll first select maybe 2D elements. And then here, let me go ahead and select all these and delete them first. And let's go ahead and select these elements. And now let me pick this new coordinate system. We'll select this one, click OK, then apply. And there you have it. So now all the 0 degree directions are parallel to this coordinate system here on the left. Now, there are so many ways to do this. Here is an alternative way. So here for these elements and these elements, I use 2 local coordinate systems. For these elements at the top and the left, I'm going to use 1 coordinate system that's slightly angled like you see here. So you can see the x-axis of this coordinate system is going along this direction. So we're going to make all these 0 degree directions. I don't know if parallel is the right word to use, but you can think that we're projecting this vector onto the element surfaces, if you will, and we're using that to orient the 0 degree direction. So here, let me do it now. Let's go and delete the old element IDs. Let's click on coordinate system. So we'll go ahead and pick this one. And then for the element IDs, let's go ahead and pick all the elements at the top. And again, sometimes all the visual objects interfere with picking, so you can click on reset display to remove them. Click the plus icon, and now we're selecting elements. Let's close that and let's click apply. And there you have it. So let's go ahead and look at it before. So before, these were the 0 degree directions. The red axes were the 0 degree directions. And then we clicked on apply, and then this is our update. You can see the 0 degree directions are now going along the same direction as this x-axis in this local coordinate system. So if we look at the box now, you can see if we were draping our fiber, you can see we were draping this direction, along this direction, along this direction, and along this direction. Whereas before, the 0 degree direction was slightly pointing in different directions. It was subtle, but it was there. Okay, now you might be saying, you know what? I want them all to go along the x-axis of the basic coordinate system. So if you look at the bottom left, this is the x-axis. I want my 0 degree directions to go in that direction. So how do we do that? So we'll use the MCID option. And one thing that's sort of not visible, let me see if I can display it. Here, this would be the basic coordinate system. The ID is 0. It's in the model, but it's overlapping with the mesh. So that's why it's kind of hard to miss, or it's hard to catch rather. It's hard to look. So it's there. We're going to use that coordinate system to align the 0 degree direction. So let's go ahead and go back to orientations, 2D elements, MCID. For the coordinate system, we're going to pick this coordinate system. Notice that it turned blue. It's very subtle, so make sure you keep an eye out for it. And then for the element IDs, let's go ahead and see what we selected. Okay, so maybe we want to add on to this. Let's go ahead and select all these elements. And we'll go ahead and do that for these. Or maybe, you know what, I will not do it for these elements, just so you see what the difference is in a moment. Click apply. And now you can see that all these elements at the top, the left, and the bottom, they're all going in this direction, which was the x-axis of the basic coordinate system. Now, what about these elements that we did not modify? These are unmodified, so they're still going in this direction. If we want to, we could say, you know what, include these in the modification. Click apply. And now they're also pointing. So this is now my 0 degree direction for this laminate. Okay, there you have it. So for the first part of the video, we defined these vectors to orient the 0 degree direction. And then in the second part of the video, we use coordinate systems to align the 0 degree direction. Now, what is easier? After experimenting with all of this, my personal favorite method is the theta option. You can either use 2 nodes or a vector. So either of these options, for me at least, was the simplest. The alternative is to manually create all these different coordinate systems and then associate them here in the orientations panel. So it's my personal opinion that the theta method is the easiest. The MCID method also works, but it takes a little bit more work because then you have to create all these additional coordinate systems. We saw that the issue with the 0 degree directions happens whether you're using quadrilateral or triangular elements. So here we're looking at the ECS for both of these examples. So again, the 0 degree direction issue, that's going to happen if you're working with 2D element, or sorry, quadrilateral elements or triangular elements. It's more pronounced in triangular elements, so that's why I decided to include triangular elements here. In aerospace, you never use triangular elements. In a majority of cases, you're dealing with quadrilateral elements. But here, I know some are using triangular elements for composites, so I decided to throw that in here. Okay, let me look at the new MCS here and here. And let me recap what we did in this video. So we went ahead and we modified the PCOMP entry. We added some additional layers, if you will. We then went ahead and saw a preview of this. I think it was in this one, actually. So we went ahead and built or updated the PCOMP entry. We added a new layer with 68 degrees. We saw how the PCOMP entry was written out. We saw a preview of this. So as we were building the laminate, we got to see what the layers look like. And then, very important that we look at the 0 degree direction. So we went ahead and took time to make sure that the 0 degree direction was to our liking. There were different options to do this as I experimented with it. Remember, most tutorials, they will only show you how to define the PCOMP entry, and that's it. It's very important that you also adjust the direction of the 0 degree axes, or else you're going to have a lot of issues later on. So in the second part of the video, you saw me adjust the 0 degree direction. Now, there's one other thing I wanted to cover, which I'm covering in a future tutorial. So PCOMP, let me see if I can find that entry. Some of you might want to export failure indices. A lot of the time, or rather, in order to get a failure index, you need to specify a list of values. So if you look at the PCOMP entry in the quick reference guide, if you scroll down a little here under failure theory, click on C remark 7, you see this. In order to get failure index output, the following must be present: stress and strain, and there's a long list of values you have to supply. In a future video, I'm going to walk you through how to supply these values so you can get failure indices from your laminate that you define. But this video was all devoted to just defining that PCOMP entry and the direction of the 0 degree axes. Okay, so that's pretty much the end of the video for today, and as always, thank you for watching.